Hey all, here's our next video. This is on remainder and factor theorems. So in the last video in class 1.6 we talked about dividing polynomials and using synthetic division to do that. And this is with division, but we're not actually doing any dividing. We can use these two theorems, the remainder theorem and the factor theorem, to find out two different things. So in 1.6 in the last video, we talked about remainders. It's the extra leftover parts when you divide. But without dividing, you can use the remainder theorem to find the remainder of two divided polynomials without actually dividing. And also, you can figure out if two polynomials are factors of each other by using the factor theorem. And this means we can use the factor theorem to identify whether or not two polynomials divide evenly without actually dividing them. That should be under dividing evenly. I don't know what I'm doing here. Alright, so first the remainder theorem. The remainder theorem says if a polynomial f of x, okay, so in my example here, this is the f of x. Here I have this polynomial. It's divided by x minus k, so here we have x minus k. So you'll notice that in this case, k is 4, right? We learned in our last video that we can do the x minus 4 equals 0, which will give me that x equals 4 when I add 4 to both sides. So in this case, k equals 4, right? The remainder you can find without dividing by doing f of k, okay? And so hopefully you remember this notation from functions. But therefore, the remainder r is equal to f of k. So in this case, k is 4. 4 is going to go in here. So in this case, my remainder is equal to f of 4. And so you'll remember that 4, when it's inside the parentheses here, I plug it into the function. So basically, I'm going to plug in 4 for every single one of these x values. Okay? And then simplify, and whatever I get will be my remainder. So 8x to the 4th means I have 8 times 4 to the 4th power minus 34 times 4 to the 3rd power plus 4 times 4 squared plus 6 times 4 plus 44. Okay, from here I'm going to simplify. They didn't take out a calculator, so I got to do that. So, PEMDAS, parentheses first. Alright, I can't simplify anything in here, but I can MDAS. E is next. So 4 to the 4th power is 256. So 8 times 256 minus 34 times 4 cubed is 64 plus 4 squared is times 16 plus 6 times 4 I know is 24 plus 44. Keep simplifying. 8 times 256 is 2048 minus 34 times 64. Nope, 34 times 64 is 2176 plus 4 times 16 is 64 plus 24 plus 44. Now I can add all these together. Let's see. My calculator. Whoops, should have been doing this the whole time. Sorry. 2048 minus 2176 plus 64 plus 24 plus 44 equals 4. And so my remainder here is also 4. I know that was also my k value. And that might not always work out to be the same, okay, but in this case my remainder is 4. So, and that's what I asked for, right? Find the remainder. So that's it. There's my remainder. Alright, so here's our die roll. Alright, add up this sum here and enter it into the CPP. All right. The factor theorem says a polynomial function f of x has a factor, divides evenly into x minus k, if and only if, hopefully you remember this notation from geometry, remember IFF? So biconditional term means we can go from here to here and backwards from here to here. If and only if f of k equals 0, okay? We just found out that f of k equals 4, right? F of k is the same thing here as the remainder theorem, f of k. When we solved that, we found out that my remainder was 4. But we don't want that 4. We want f of k equals 0. If it's 0, then it's a factor. Means it has no remainder. They divide evenly into each other. Okay? So just a note there that that's the remainder. The remainder equals 0. So let's try this here. State if the given polynomial is a factor of the given polynomial. Well, in order to do that, I need to find the remainder. And so I'm going to end up using still my remainder theorem here. Same process. So here I have x plus 2 equals 0. Subtract 2, x equals negative 2. Okay? With that negative 2, I'm going to plug it into the x's. That's my f of k. So x cubed is negative 2 cubed minus negative 2 squared minus 2 times negative 2 plus 8. Simplify. Negative 2 cubed is negative 8 minus negative 2 squared. Oh, 2 negatives makes that a positive 4, but there's still this negative. Negative 2 times negative 2 is positive 4 plus 8. Well, this is negative 12 plus 4 plus 8. Negative 12 plus 4 is negative 8 plus 8. Oh, look at that. Ms. Schulte must have picked this on purpose. This is 0, and therefore this is a factor of this because my remainder turned out to be 0. So yes, the binomial is a factor. Yeah. Oh my gosh, I'm so bad at this. Okay. Just to show it one more time, I have my example over here. B minus 5, so B minus 5 equals 0. B equals 5. Okay, so this 5 I take in, do the f of k, so I plug it in. 8 times 5 squared minus 38 times 5 minus 7. 5 squared is 25, so 8 times 25 minus, again, 38 times 5 is 190. Minus 7, 8 times 25 is 200. Minus 190 minus 7, 200 minus 190 is 10, minus 7, 3. Well, this is my remainder. It's not 0. So therefore I have a remainder, and the given binomial is not a factor. Okay? Alright. See you in class. That's remainder and factor theorem.